Hi, everybody. My name is Olga Kurnan. I am a university project coordinator at GlobalLogic Ukraine. I'm glad to see you all at our first webinar for students from Ukraine, Poland, Slovakia, and Croatia. Today we will speak about big data, and pleasure to introduce our speaker, Alexander Fedirko. Alexander is our GlobalLogic practice head of big data. He is responsible about big data practice in the region of Central and Eastern Europe. And before we start, I want to say a few words about our rules of the webinars. If you have any question for the speaker, you can write it at the Q&A. Alexander will read and answer them at the end of the webinar. And approximate time of our webinar is an hour, 40 minutes for a lecture, and 20 minutes for question and answer. Alexander, are you ready to start?
Yeah, hi everyone. So let's see. For today, we have a great opportunity to conduct this webinar and share with you guys one of the topic that we read this once in the GlobalLogic in Kiev office, and today I'm glad that I can present it for you. Okay, let's see. As Olga mentioned, so for today with you, it's me. I'm your speaker. I'm a head of big data practice. My actually responsibility is to growth community of big data, make popularization of big data, start big data projects, all pre-sale activities, all kind of architecture and so forth. I really like big data and all around it. So yeah. And a quick agenda for today. This webinar is actually focused on let's say basics of the streaming. So if you have any experience, or maybe you didn't have any kind of experience, you might ask questions like, how do I start? What do I have to know? If you have a project in GlobalLogic, what kind of questions do you ask on this on the meetings? If I have to start, if you have an open position. So all of these questions, they kind of typical, and I think for you guys, even if you experienced, you maybe gonna find something useful for you. Okay, so we're gonna jump to the very basics, but they kind of essential. You're gonna see them all the time, everywhere. I'm gonna show you a couple of the architectures, how it looks like, how can you consume data in the streams, how can you sync data in the streams. I'm also gonna jump to the tools overview. Let's say I would like to highlight major tools. What do we have on the market? And at the end of this session, I'm gonna show you one architecture, one picture of the stream processing that we have at one of the GlobalLogic's project that we have in Kiev and Kharkiv office. And of course, of that, you're gonna have your chance to ask your questions. So let's move. Let's start with the basics. You're gonna hear this everywhere. It's not just a stream things, but you're gonna hear this kind of words like stateful and stateless. It's type of operations that you can do. So every time when you have a stream and you have a lot of elements in the stream, and you do something only with just a single element, only with a single atomic message, or let's call this message. So that's going to be a stateless thing. So kind of operation like filtering or maps, that's a stateless operation. But if you have to take in account all kind of your messages in the stream, that's a stateful operation. So if you need to transfer from source 1 to source 2, and they have to exchange data between them to solve your problem, that's a stateful problem. So yeah, and if you have in the stream such kind of things like aggregation, like sum, average or, I don't know, count, that's a stateful operation. If you have a join, that's stateful operation. Sorting, if you need to sort, that's also stateful operation. That's, yeah. Another thing that you also might hear in the streaming processing, that's about your sources. They could be called bounded and unbounded. What's the difference? So if you read at once the whole source, like a table from database or flat file or some collection from key value storage, that's a bounded if it has a limit from the beginning and to the end. But if you have no end and no, okay, you have starting point, but you have no end point, it's never-ending source, like queue, your Kafka, your RabbitMQ, or any kind of queue, your port, you can listen message from port or from socket. That's unbounded sources. Interesting thing that every bounded sources, like I mentioned, flat file and database, could be unbounded. So for instance, you can read never-ending file that would be always populated. You can open file and read all the rows from this file, and that's going to be unbounded. But I would say typically at the architecture, the designs, so that's how your source looks like. They rather bounded or unbounded. Okay, let's move on. So what's your stream? Stream, let's imagine that you have some kind of sensor that sends you value in the manner like of the time, like every second. If you have this never-ending values, and the ask for your side is, could you count some of these values? How would you gonna do this? You can actually start counting from some point of time, and you're gonna have never-ending sum. It's like we have new value, you add the value. You got more value, you adding. So you have your rolling sum that never ends. And that's actually also makes sense. Like you just counting all the values that you have in your stream. But for the real life tasks and business problems, you rather have to define a window. So that's also at every stream system that you're going to find that you're going to see such kind of things like windowing. Don't mess this stream window with analytical window in the SQL or other static batch processing. It's two different windows. So this window, you have to define like what kind of window you're gonna have. How would you split your elements by different rules? And so in this particular example, that's what we call tumbling window or fixed window. In this particular example, we define that every 4 elements, we're gonna have a window. So instead of counting never-ending sum that gonna need a stream, you have to split by this windows and counting sum just in your window. So at the same example, you're gonna have 3 values that says, okay, you have 8, 22, and 27 instead of some big value. And we have another type of window. So what if you don't need a window that starts and ends immediately after the previous window ends? So there is another type of window. We call this sliding window. And we have to define for such kind of windows size of the window. Keep in mind that for this one, you have just to decide a size, for instance, 4. For this kind of window, you have to define 2 parameters. First one, size of the window, 4, and step or slice, or it's more likely like, or shift. That's in different systems, it's called in different way. So for this particular example, there is a step 2. Every 2 elements, we're shifting our window. So in this case, you're going to have multiple windows. And you're going to have a sum of every your window. And you can calculate this. Why do you, if you count sum, you might ask a question, why do I need this? Because the same element, like 8 in this example, or let's say 8 and 4, they presented twice. So if you aggregate all of your values, you're gonna have a double sum of all kind of elements. But think about this: sum is it's not the only one aggregation function that could be. For sum, it might be. You're right that it makes no sense because we're gonna have a duplicated value. Everything we're gonna have a bigger twice value. So, but another different type of aggregations, like max function, that makes sense because for different sliding window, you're gonna have max value different. So it makes sense for some of the aggregations and some of the business needs. Okay, let's move on. We have simple cases like when we have every element just have single value. But what if you have key and value, 2 pairs? You can actually define a window based on the key. So, for instance, you're gonna see here that we have a tumbling window with that has a size or its window size 2 for 2 elements. You see, it's every 2 elements. So the size of the window is 2. And the aggregation happening by the key. You combine your values by key, and you do sum of your value. That's also a kind of typical thing. Like you have key value, and you have to aggregate by key. So yeah, at this particular example, you're going to see that we have 2 windows. On the left, they are black. You see their tails. There is no their first element. It's somewhere on the left. So yeah, that's basic things. You have to keep in mind there is a windows. We need them just for the stateful operations. So if you don't have a stateful operations in your stream, you probably don't need window. Every map, filter, they don't require all this type of definition of the windows. But if you have any kind of stateful operation, that's where you have to define them. And also, it's also applied just for your in most cases, just for your unbounded sources, where you have never-ending stream that has no end and no beginning. Okay, let's move on. There is a couple types of stream systems or engines that we have a definition between them. I do believe that we have more than just this one and the next one. We have more options how to split them, but I would like to highlight this major two, let's say, their characteristics. So one of them, you probably gonna hear like, is it micro batches or is it a real-time streaming? So I would say most of the tools and frameworks, they actually oriented for the micro batches. They don't do your operation immediately. They try to make some small batches and apply all of your operations in these small batches. That actually makes sense. Think of this. These micro batches, they could be their delay could be less than about this second, 1 second. Do you really need so real time when you have something that has very low latency, less than a second? It's really about the business needs. Your business has to define, do you really need real time, or are you okay with close to real time with micro batches. And let's say for the frameworks that you're gonna see or tools, most of them actually has a micro batches paradigm. And but we all, of course, we have real-time streaming that it shows a better performance with stateless operations like maps and filters. And if you have a real business case that need this real-time streaming, so it's always an option to switch from micro batches to the real-time streaming. Another one that's more historical split. Back in the time, you have to define for your stream processing so-called DAG. You're gonna hear this DAG, directed acyclic graph, many times in your life. Trust me, nowadays it's widely used. But you have to define the map, let's call, how your processing gonna work and so forth. So you have to configure this DAG for your stream processing, and then you start your stream processing and it works. You're gonna hear this one of the tools that kind of popular, like Apache Storm. If you have this on a project, you most likely know what does it look like. I'm gonna show you actually on the next slide. New wave or modern wave, how do you define stream business logic? It's declarative engines. So you, instead of defining this DAG and graph, how you move from one state to another, you define in a SQL manner, like what you would like to get. So if you heard of a Spark, Apache Spark or Flink, they do use this paradigm with declarative. Of course, for me, the most convenient one is the second one, declarative way. I really like how you can define in a simple way your stream business logic. Okay, let's move on. How would you use your stream tools? So typical things like you have on the project, you have your sources, you have your layer for ingestion. That could be sources. Typically, they could be a pull type. Sorry, push type. When you have you don't have to pull your data to your system. So if you have a push sources, then you have ingestion layer. What it could be like ingestion layer, like NiFi. If you have heard of this, that could be your ingestion layer, or some connectors of your queue. For instance, if you have Kafka, you're gonna see Kafka connectors. That could be also your ingestion layer. Then you might, after the queue on your platform, you're gonna have stream processing. Stream processing could be Apache Spark, for instance. And at the end, you would like to put your stream data to the data lake. That's one of the options how you could consume your stream data. Another option, why do we need the ingestion layer? As I told, most of the queues, they have connectors once. Another thing, you might have your sources might push messages directly to your queue on your platform. So you might have no ingestion layer at all, and everything gonna be the same. Data lake, it's one of the options where you could put your data. But what about the key value or columnar storage? They also very fast and write-oriented. You can really have a big stream and big throughput and put all your values from the stream to this kind of key value storages. Another one thing, when you're gonna have interaction of your stream with the queue. So previous designs, they were, let's say, oriented to the stream transforms your stream processing tools. They transform your stream data to the, let's say, batch-oriented data. So, you know, when you put your data to the data lake, it's most likely going to be consumed in a batch manner. But what if you have a complex business logic, when you have to consume from queue, transform your data, and put to the same queue backward. So, and that could be a complex project with multiple steps, like you consume something from queue and put to the queue backward. And that's another option how you can work with your queue. Actually, you can combine all this type of approaches, and your stream could put your data to the data lake after the complex processing. You can also consume data from bounded data sources, like you would like to grab something from the database or API call and keep this in the stream, in your stream processing system. So that's also an option. Or you can combine all of these types of architectures. We're gonna jump to the case study at the end, and I'm gonna show you how do we use on the project all these approaches that we have discussed today. Okay, if you just have a plan to use a stream on the project, what you have to keep in mind before you start. And of course, you have to keep, there are two types of requirements: functional and non-functional requirements. Functional requirements you can find out with your business. Okay, what you would like to get. Do you want that we have counts or sum? How you would like to consume your data? That's how your business is actually know how to define this. But what I saw on the projects, the biggest problem goes with non-functional requirement. A lot of architects and developers, they just don't care about non-functional requirement, and this could make a lot of problem. So you have considered such kind of things like how big gonna be your throughput, because for instance, if it's just 100 messages per second, you're gonna have a simpler tool to process this one, or you have to think about infrastructure. Is it just a one virtual machine to process 100 messages per second, or but let's imagine that you have thousands and thousands messages per second, like millions messages per second. You have to think about what kind of tool you're gonna pick in this case, and what's gonna be your infrastructure for such kind of big throughput. Consider records per second in the spike, because there's typical case like you have small value in average, but you have spikes when you have your throughput doubled or quadrupled or even 10 times bigger than your average value. Also ask about the spikes longevity. So for how long you're gonna have these spikes? Is it 5 minutes, 10 minutes, or hour? It's also kind of important. You have to know your stream record size. So for the 95%, what's the average size of your records? Is it 10 bytes, 100 kilobytes, 1 megabyte? Actually, in my personal opinion, if you have a message maximum value of your message bigger than 1 megabyte, you probably do something wrong. So I would think about, do you really need stream or something else if your single message has a size bigger than 1 megabyte? Also keep in mind of 1% of your biggest size record, because systems, queue, for instance, it's very important for queue like Kafka and so forth. Some of them, they have limitation of the maximum size of the record. So it's very important to understand your stream. Also ask about the latency. Do they really need this less than seconds results, or are they okay if you're gonna have 5 or 6, I don't know, 10 seconds delay? So it's also kind of important. You're gonna hear such kind of things like exactly one, at least one, and at most one semantic. What does it mean? So if you have the demand from business, like we have to have exactly one. What does it mean? If you have one message in your that come into your stream, you have to have exactly the same amount of message out of your stream. For the huge performance, it might be a case when when we're gonna have a good performance, but you have to pay for this. So in this case, you might lose a message. So that calls at most one semantic. So it's 99 and 99% of your messages where this could happen. So for instance, if you work with IoT and all these meters and so forth, if you're gonna lose one messages per million, no one cares. It's just that you have a lot of them. Why do you need this? But if you have a business operation that works with money, it's kind of important to make sure that you're gonna guarantee delivery and you have exactly one paradigm. And what does it mean, at least one? So at least one says that you might have duplicates in your output. So you definitely wouldn't lose the message, but you might produce duplicates. When we might see duplicates, do you remember sliding windows where we have overlaps of the windows? That's actually the case when we might gonna see duplicates. So you have to define this business. Are they okay if we lose a message? Are we okay if we're gonna have duplicates? If you have duplicates and business is not okay with this, can you deduplicate your message? So yeah, it's there is a techniques how you can deduplicate your message. Ask your business about late arrivals. What does it mean? If you have defined a window in time based on time attribute, and message just lost somewhere at your upstream, and it come to your system late, do you really have to take in account this, or you have to ignore this message that came very late? Typically, you can define like, okay, if you have a size of the window 5 minutes, what I say, my suggestion is to keep late arrivals for 15 minutes. What does it mean? So every message that come in this interval of the 15 minutes, you take in account to this 5-minute interval. So you're waiting just 15 minutes. Everything that after this 15 minutes, you just ignore. But late arrivals, that's kind of, let's say, tough topic to discuss. Another one thing you have to ask your business and keep in mind, would you gonna have static stream rules or is it dynamic? What does it mean? Static streams that you start your stream job and it just works. You don't need to define to restart, to manage somehow your job. It just starts and to do its job. Most of the stream jobs, they actually works in this manner, but it might be a case when your business says, okay, I want to adjust business logic and make these streams dynamically, starts and shut down. So in this case, you have to, there is a problem. You have to also deliver this manager of your stream jobs. That's kind of also challenging thing. Okay, let's just make a quick look at the tools that we have on the market. One of the most, let's say, major player on the market and the most popular tool is Apache Spark. You probably have heard of this a lot. It's open source. It has 10 years of the history. You just pick it and you can use it with most of your favorite languages like Python, Java, and so forth. It has even SQL on top of this. I don't remember, do we have SQL in the Stream API? But you definitely can code with your favorite language. So for instance, today at the current project, we have Apache Spark with Scala code. What kind of benefits? It's it has mature infrastructure. It's more than 10 years of history of the Spark. But Spark is kind of, let's say, big engine, and you have to maintain it. You have to understand how it works. So keep in mind, if you're okay with latency of few seconds, that also would work for you. Apache Storm. It's an old school streaming tool, but it's also widely used in the project. So you might gonna see this one at the customer's project. That's how it looks like your definition of the DAG, directed acyclic graph. So you have to define your sinks and your transformations, and you have to define this moves from one state to another. If you want to real-time processing, that's one of the options for you. But you have to keep in mind this declarative design. Not a declarative, but this this DAG definition. Another, let's say, modern approach how you can work with stream, it's Apache Flink. So if you know that you need real time with no delay stream processing, and you have your project from scratch, that's one of the options how you can start. Just take a look at Apache Flink. It's about 3 or 4 years old, but I would say they have a great progress. They have implemented a lot of things. Community contributed a lot of things that it develops really quick. So yeah, stream first approach for the Apache Spark. It was initially designed for the batch processing, and then adjusted with all this resilient with RDDs to the stream. In the Apache Flink, they intentionally and initially designed this tool to the stream processing, and this how you could get real-time processing of the data, real-time streaming, and declarative way how you can design your stream business logic. Also keep in mind that if you're gonna have any cloud provider at your project, most likely this cloud provider has stream processing as a service. So for instance, if you do use AWS, most likely you have to take a look at Kinesis. If you have Google Cloud, it's Dataflow. For the Azure, take a look at Stream Analytics. So your cloud provider has a tool out of the box that has to simplify for you provisioning of the infrastructure. You have just to define code and say, okay, I want to run this stream, and they're gonna do everything for you. So yeah, that's so if you have a cloud at your project, I would recommend to take a look at the built-in platform as a service tools that you have. Don't try to provision your own Spark cluster. You have to really understand why do you need your Spark cluster on the cloud. So I would recommend to take a look at built-in platform as a service offerings from the cloud provider. Also one of the questions that I saw, it's like I have my Lambda applications on the cloud. Is it considered at the stream? Do I need to use this instead of the Sparks, Flinks, and so forth? Yeah, I would recommend to do this if you have a very simple and lightweight logic. If you don't need to make a lot of chain transformation in your stream, and you don't need to make stateful operations, if your transformation kind of simple, why not? Just write your Java application or Python application and upload this to the serverless infrastructure. That would work. That would work. I saw this many times, and it's fine. You don't need some special dedicated stream service for all your needs. That's true. Let's take a look at the case study. That's one of the projects that I was involved in as a data architect. So what do we have? We have a stream of events, and the requirement from the customer was, I want to define my own business logic with. So you're gonna see these two words here on the top, like CEP, that stands for the complex event processing. That's a general name. If you Google CEP or complex event processing, you're going to find how this could be solved. DSL stands for domain-specific language. So customer wants their own language that they could define stream jobs and make this complex event processing. If you have a stream job that consumes something from Kafka and put it back with some kind of transformation, that most likely you can call a CEP, complex event processing. So on this diagram on the left, you're going to see, let's say, our Kafka, our queue design. That's a list of the topics. In the middle, it's a stream engine, and that's a list of the jobs. I don't say that it's a Spark job. It was Dataflow jobs. And on the right, we have a persistent layer, storages that we have. So we have to define 4 static jobs and unlimited amount of dynamic jobs. So if you see this rules job, that's it's about the dynamic jobs that customer defined by himself. But this 4 on the top, that's supposed to be a static job that just listening Kafka topic and do their transformation. So you see in the design, that might be like we grab something from raw events, we have to archive them and put directly to the archive chip storage, or we have to parse these events and prepare them, put to the another type of storage, and so forth. We can process by our dynamic rules this parsed event, indicator, and incidents, and that could be let's say couple chain process. So you might consume messages from indicators and incidents topic, you process them somehow and put them back, and so forth. That's how it was work. What kind of technologies we did use? As a queue, it was a Kafka. It really has a good performance, and we need on this project exactly one semantic delivery guarantee. So Kafka works fine with such kind of problem. It can guarantee for you delivery of the message. For the processing engine, it was Dataflow on the Google Cloud. Actually, all infrastructure was in the Google Cloud. As a persistent layer, it was Google Bucket as archive storage. As a primary storage, it was BigTable. As secondary storage, it was Elasticsearch. And as application storage, it was Postgres. So yeah, one of the challenge here with these dynamic jobs, we have to define, of course, our custom language and translate from customer-specific domain language to the stream API, and provide this fancy UI how you can define your stream jobs. Also, we have to write down and design our stream job manager. There is no good way how you can actually start, stop, restart your job. So yeah, it was also our own application, Java-based application that manages jobs and checks their status, show is it running or is it suspended? Can we start, restart, or stop the job? So yeah, keep in mind, so if you have a definition on the project, like user has to define stream jobs, it most likely you're gonna have to make your own stream job manager. Okay, let's move on. Frequently asked questions. So of course, you're free to ask any extra questions in the Q&A session, but I actually ask by such kind of questions very often, so I would like to make this just a bit early. So if you have your own Java-based application and your Java application consumes messages from Kafka, is it stream or not? Yes, it's actually, you also can consider this as a stream. What are you gonna have? What kind of benefits you're gonna get with your custom Java-based application? You are not limited for any framework or any APIs. You can do whatever you want with messages with Java. But keep in mind, if you have this benefit of do whatever you want, you also might lose a couple of things that such kind of frameworks like Apache Flink or Apache Spark, they're gonna give you, like resilience of your computation, like they have this API for the all aggregation. You have to think of all of these things for yourself. But yes, it's also stream processing. If you have your own Java written application or Python written application, whatever. Another question, if I have one message per day in my Kafka topic, is it stream or not? Actually, yes, it's also stream, but it's very small stream. And maybe you don't need Spark or something like this if you have less than, let's say, I don't know, maybe 10,000 messages per day. I don't think you need some kind of framework. You probably need some, maybe your custom application like Java-based or other integration tool that just listening for your Kafka topic and do some action. So yeah, think about this. If you have very small stream, do you really need such kind of big and powerful machine like Apache Spark or not? So another question is, oh, I have Kafka Streams API. I do use this Kafka Stream API in my project. Why didn't you tell about this one on this session? I do understand that Kafka Stream is widely used and let's say it's kind of popular, you know, and I have nothing against it. It's also it's one of the options how to do your stream processing, and it's fine. When I would consider this one, first of all, you have to have a Kafka. If you don't have a Kafka, there is no way how you can utilize your Kafka Stream API. Kafka Stream API has its own limitation and own framework. So take a look closely. Are you really happy with what Kafka Stream API provides you? If answer is yes, please do use. That's fine. Another question might be, I have another tool on my project. Why didn't you mention it today? It's a stream processing tools landscape. It's kind of wide. We have a lot of tools for today, how you can actually process your data. I didn't cover this because, yeah, we have a lot of them. And I just jumped to the most popular one. So sorry if I didn't mention your favorite stream tool and so forth. Yeah, another question. Okay, am I a stream master? I mean, you as the listeners after this meeting? Of course not. It's a lot of, maybe you are, but if you have this, if you have heard of all this paradigms, ideas, and concepts first time in your life, probably you wouldn't consider yourself as a stream master. You have to work with this. Just open examples from any stream processing tool and try to make a hello world things or something like this. It's a lot of open stream sources like social media. take a look at the Twitter API or Facebook API. You can actually connect to this stream source and make your own analysis and data processing. You can try this out and just start working with stream tools and stream sources. And a lot of things that, of course, I didn't cover, like late arrivals. I just mentioned that there might be a problem, but how you're gonna solve this? It's a lot of things. It's a lot of options how you can solve this problem with late arrivals. The same I mentioned the duplication. I just mentioned that there is a problem, but how you can solve it? It's a lot of options, and you have pros and cons with different approaches how to solve the duplication problem. Another topic that I didn't cover, like transactions of your stream, how to guarantee that you didn't lose when you consumed something, some kind of messages and put them back to the Kafka. How you can guarantee if you have a full turn off of your stream processing, how you can guarantee that you wouldn't lose any message. It's also different options how you can solve this problem with stream processing. So it's a lot of topics, and I just gave you direction. Now it's time for you to act, and you can dig deeper into this one. Okay, so that was my part for the lecture. I hope that you enjoyed this one, and I think we can go to the Q&A session. Feel free to ask any question if you're curious about. Okay, let's see. So the first one. Okay, for the end and the beginning of the particular window. Most likely, and often you have to define your window based on time. So, for instance, the size of the window. What I saw in my experience, you don't define this like 5 elements or 6 elements and so forth. You rather define time frame. For instance, 5 minutes. So every 5 minutes you have a windows, and every element in this 5 minutes interval you consider a one window. When you have a start of your window, when you start your stream, you don't define like, okay, start my window at 12 a.m. today. So you start your stream is started, that's the beginning of your window. Then when your stream process started, that's your beginning of the window. And you can then consume your messages. So if you define every 5 messages, that's the end of your window. Or a time-based window, you can define 5 minutes, that's the end of your window. So yeah, it's really about when did you start your stream. Don't rely on this too much. I mean, if you really need precise time windows, like window starts at 12 a.m. and ends at 12 a.m. and 5 minutes, what I would do if I need this? Maybe you need your custom window. In most cases, you really don't need to have precise start and end of the windows. The size of the window have to be precise. If you say it's 5 minutes, it's always going to be 5 minutes. Or if you say it's have to be 10 records, it's always going to be 10 records. But your start, in most cases, you don't need to be this precise, very precise when you start your window. Yeah, I hope I answered this question. Latency of you second. Spark, of course, evolving, and they might have a progress. You know, I didn't discover too much of this their latest progress at the latest versions. They might claim very low latency, but it's really all about the preference. What I would recommend, you know, make a POC, small investigation, proof of concept. Just try it yourself. Make a performance load to your stream and see the real throughput. You know, they can claim whatever they want. Make a real experiment. Make a real life performance testing and see what's the real latency in your particular case with your typical scenarios and how this would work. But I wouldn't do this. You know, for this case study where I show you this architecture of the stream processing, as far as I remember, we did 30 proof of concepts to find out, would this technology work for us or not? So yeah, my recommendation is try it. Don't trust their claims like we do this in less than a second. Try it and see, would this work for you or not? Okay. Whoa. IoT things. Okay. I think the first question would be about the cloud. I'm not familiar with every types of cameras and what their quality, what their let's say size of every picture taken by these cameras. What gonna be a cost of this streaming your video to the cloud? That might be let's say, I don't think that they do real stream, but by real stream I mean they don't need immediate reaction on every frame from your camera. Most likely, I don't know the architecture of this project. Most likely, how do they work? I think they store every frame from your camera to some chip storage, and chip storage have like Amazon S3 bucket. It's kind of cheap. You can store everything there and then process in a batch manner later. If they need let's say close to real-time reaction to the frames from cameras, most likely what do? I think they do reduction of your frames, so they don't react to every frame from camera. So for instance, they send 1 frame per 10 seconds or 5 seconds or maybe 3 seconds and analyze this picture in a stream mode. That could be if 1 frame gonna be about a megabyte, let's say 1 megabyte. 1 megabyte, I think it's kind of good quality for the camera. So if you have 1 megabyte per 3 seconds, you wouldn't pay too much for such kind of analysis. If they did this, let's say in optimal way, it wouldn't take too much cost. But of course, keep in mind, cloud, it's expensive thing. Every cloud is more expensive than your own cluster in terms of short-term investments. In the long-term investments, it might be cheaper. It's also a question about, do they have a special contract, Lviv city? Do they have a special contract? I know a lot of customers, they have a special contract and special discounts, like 50, 60, or 70% on the initial price. So in this case, I definitely would consider cloud as a platform, as a infrastructure for your project. So it's really hard to answer what the monthly bill for them. I don't know. It depends of how do they do processing, how many cameras do they have, what's the average size of the frame, what kind of operations, stream operations do they do. Maybe it's a cost about 10,000 of United States dollar per month. Maybe it's cheaper. Who knows? Oh, yeah, I think I partially covered the second one. Own service. I think by own service, maybe you mean own infrastructure, own data center, and so forth. For the own data center, you would pay less in the short-term strategy, but on a long-term strategy, you would spend more on operations. You have to pay your DevOps, infrastructure engineers, you have to maintain your hardware. So I think if you have a plan for your project for a year, you might consider your own infrastructure. But if you have very long term, maybe it's better to make sign a contract with Microsoft or AWS and ask them for discounts and do all those things in the cloud. No, I didn't calculate the cost. Maybe architects of this project in Lviv, maybe they did. TensorFlow, I don't know. Do they use TensorFlow at all? Maybe you don't need TensorFlow at all. You know, you have a lot of. You can describe a lot of operations without machine learning and AI frameworks. Sometimes you need them, sometimes you don't need them. It depends what kind of operations you would like to have with your images, with your frames from camera. So I don't know what's gonna be a benefit of of savings for the cost. Of course, you have to try different approaches and take a look. Maybe that's gonna be enough for you to have Apache MLlib, or maybe you need something more. There is also, if you in this topic in the machine learning and AI, I would recommend to take a look at the cloud services, what they have built in and out of the box as a platform. So maybe you're gonna have something like voice recognition. Do you really need the voice recognition and make it by yourself? Because a lot of cloud providers, they have text to speech and speech to text built-in services. You're most likely gonna use their services instead of making your own machine learning and training your own models. So yeah. Okay, let's see. Security, I would generalize the last question about the security. Security kind of important from business perspective, from your requirements. I would recommend to use general approach. Everything that you do use in a typical project, you have to consider on the stream projects, like end-to-end encryption. Ask your business has to define, do you need this or not? Compliance with, do you have sensitive data? You know, at European Union, at United States, you have a lot of regulations that sensitive data of your customers, they have to be protected. So everything applied here. You have to ask a security officer or your architect or your business, a lot of stakeholders for security perspective. Do you need to do this or not? Of course, VPN is one of the options how to protect or anonymize your data. So yeah, take a look at the security options of your stream processing tool. What they have. Okay, we have another one. Can you secure Kafka topics? By secure Kafka topics, there are two options how you can secure Kafka topics. You rather secure connection to them. So in this case, if you would like to enable end-to-end encryption, you have to enable SSL. So of course, do not use Kafka, do not consume messages from Kafka at the unsecured channel. Just use SSL and TSL. And if you're talking about encryption of the content, I think there is an option how you can enable it. I think it's built-in functionality in the Kafka. You can build encryption of your content. So that means even if your hardware stolen or compromised, no one would get, no one can encrypt your content of your Kafka topics and so forth. Yeah, just take a look at the documentation. I'm pretty sure Kafka has encryption of the content. Okay, I hope that I did answer to all your questions and you got all you need. So
thank you.
Yeah.
Thank you. Thank you, Sasha. Thank you all. I see one new question.
Oh. Let's see. Oh, okay. Okay, that's about the first one thing. I think it's about the compliance, about the government and how do they interact with cloud. It's actually not true that you could not use a cloud bucket, because first of all, you have your private cloud that has no access for public. So you actually can use. You also can apply encryption of your archive. So for instance, for this project, I mentioned archive storage. It was Google Bucket. All the data, of course, was encrypted. So even if it's stolen, it wouldn't be decrypted easily. We have a high level of, let's say, reliable algorithms, enabled reliable algorithm to encrypt the content. And without the keys, decryption keys, you wouldn't get there. So it's a matter of how do you store your data. So I don't think there is a restriction with cloud. But I know that some of the governments, they do not use cloud providers. That's true. That's true. But I don't see really a big threats on this one. Private cloud plus proper encryption, you have a very well protected your data. They're using TensorFlow Lite. Maybe, I don't know. I didn't see, let's say, architecture of this part. Maybe I have to get, let's say, more familiar with this one. I didn't see the architecture. If they use TensorFlow Lite, that's fine. That's fine. Let's say in this term of the image processing, what I would say for the high performance, if you really have big throughput and you have really high performance requirements, most likely you even have to switch from your TensorFlow Lite, and any other framework to the custom written C++ applications. You know, if you want even better performance and you have very strict requirements, the next step gonna be rewrite your TensorFlow-based transformation to this custom C++ code. That would perform even better. 2 types of cameras. That's great that we have these 2 types of cameras. Okay, the last one. Was it R&D or custom? Custom, yeah. Customer paid for this project. That was 30 members team that was assigned for more than a year for the project. And of course, if you're curious about why customer allowed us to perform proof of concept on the billable project, that actually makes sense. If your customer mature enough, and it has to understand that your data engineers and architects, you don't have to know all kinds of tools in the world. You have to make a test. You don't do tests for forever, for months or 2 months. You do small proof of concept for a week, maybe, or 2 or 3 days. And you have to rather get an approval, like, okay, we are okay with this tool, and we move on with this tool. It fits well. So it was a question about the big table. Do you really know is it good for your performance or not? How can we get this? There are a lot of storages at the Google Cloud as alternative to the big table. We have, what do we have? There is a database, data span, data store, or something like this. That's a bunch of services. And the question was, which one fits very well for our particular problem to solve our particular need? So it was a POC for a week, and we decide, okay, we're good to go with big table. Yeah, that's how it works. If your customer says, okay, you have to be a professional, you have to know all kinds of tools, probably your customer is not mature enough. You have to speak and talk with your customer and explain what kind of benefits your customer gonna get with this small research things. So do this small research. Do not hesitate. Ask your customer. If you work for GlobalLogic, ask your manager how you can complete proof of concept outside of your project. That might be a thing like your customer don't want to pay for the resources for your POC. Ask GlobalLogic to provision for you cloud dedicated for your this proof of concept. Do the small researches on the project. Do not hesitate. It's better that you would try this out and find out for yourself, would this work or not? It's better to do this when you just pick some technology randomly, or you read about this something. Just try to really make a performance testing with your customer or even without your customer. That would work. I promise you. Trust me. Okay.
Thank you for your questions, guys. I will send a feedback form for you. Please write topics which you want to listen to as a part of our webinars. Thank you, Alexander. Have a nice day. Stay home and be healthy.
Yeah, good luck for everyone. See you.
Bye.
Bye.